Hi. Good morning, and sorry for the delay. We had some technical issues with the HDMI adapter. Usually my local Wi-Fi breaks because I want to show you some real-world samples later on, and that's always a little bit fragile, but fingers crossed that this will work that time. Anyway, I'm glad to be here and to talk about in general, the Internet of Things in the next couple of minutes, because the physical web is just a very tiny, a very small part of the Internet of Things, and honestly, just showing the physical web is done in 5 minutes. So we have plenty of time to talk about the Internet of Things, scenarios, ideas, some technical samples, and if everything goes well, in the end, I like to show you some smart home integration together with the physical web and Minecraft, and how you can most likely code it yourself, or you can make your own experience. But just as mentioned, smart home is just the most popular sample of the Internet of Things, of the physical web. And here you can see a smart sample with a smart home which is connected via voice, a voice-connected smart home. It's called Hello Barbie Dream House. So if you want to make your own experience with the physical web and the Internet of Things, and you don't have any clue how to start, then you can make this great bargain and buy this Hello Barbie Dream House, I think in October or November. It's just for, I only know the euro or the dollar price. It's around about $300 US, and then you can control your small smart home via voice. You can turn on the party mode, you can call the elevator via voice, and you can turn the stairs into a slide if you like that. So that's just the beginning of the Internet of Things, and nowadays you can also connect your real home, and not only your real home, you can almost connect everything, and that's somehow scary. That's anxious for most of the people. They have not a good gut feeling while connecting everything, and in most cases that's because of people fear change. It's just a change. It's a kind of new technology which somehow will change our daily life, our everyday life, and the everyday things around us. And that was always the case. If there's something changing, people fear that, it feels uncanny, and the people have their doubts. That was the same, for example, with the invention of trains. When trains have been invented, the fastest transportation have been horses, and horses are around about 20 miles per hour. So academics and doctors, honored academics and doctors, they really said everything faster than 20 miles per hour, like a train, will somehow make you crazy, and if it's going faster than 30 miles per hour, you will probably die. That was really the opinion of a lot of people. And nowadays, we're traveling with trains with more than 300 kilometers per hour, even with planes much faster, and most of us are not stupid and still alive. And that's not only one of the concerns, not only this fear of change. The other thing is that much technology is way underrated. For example, when cars were invented, a lot of people thought that's just a small thing, and nobody will talk about cars in a few years anymore. It's just a temporary thing, and horses will be the most popular transportation in years. But you all know that cars are the most popular transportation nowadays. Even Daimler, who is one of the inventors of the car, he said at the beginning, there is a market for at maximum 1 million cars worldwide. That was his real opinion, even building cars, because he said there will be not more drivers in the world, not more chauffeurs in the world for driving cars. Luckily, we can drive cars ourselves nowadays, and therefore there are much more cars in the world. And that's the same feeling I have with the Internet of Things, that there are a lot of people underrating that, some people are overrating that as well, and a lot of people have a lot of fears about this change. But the Internet of Things is not that new anymore. It's not just an invention of the last few years. It's there since decades. The first thing some people call the beginning of the Internet of Things is these ATMs. ATMs have been installed the first time in Sydney, 1967. That was the first time people did use somehow connected devices, distributed systems with a relation to the everyday life, to real things, to money in that case. Most people say that the beginning of the Internet things has been this vending machine in '82 that was invented by a university, by some students which had the real needs. They wanted to know if there's really cold Coke in the vending machine before they go to this vending machine, and therefore they did extend that with kind of connectivity. Nowadays we call that machine-to-machine. Machine-to-machine is very similar to the Internet of Things. The most important difference is with machine-to-machine you really can earn money. Internet of Things is much more kind of a buzzword, often used by marketing departments. The most important change compared to this vending machine and the ATM is that these devices are getting smaller and smaller. This is, for example, an SD-mode beacon, and SD-mode beacons are by far the biggest beacons you can buy. They are some much smaller and also very much cheaper than the SD-mode beacons to connect things, to get things into the Internet. And the paradigm did change dramatically, because in the past we tried to digitize everything. We tried to get devices, data into the Internet. By nowadays, with the Internet of Things, we try to do it the other way around. That's what we call physical web. We try to get the Internet into the devices. So that means that everything in the world gets kinds of an IP or a URI, a unified resource locator, a web address. And if you have the physical web on your phone, for example, here's somewhere a beacon installed for the current schedule. So we did extend this real-world thing, the whole venue, the event here, with the website for the schedule. So if you have your phone activated with Bluetooth and the physical web or a Chrome installed on that, you get that in your notification area, in your message center, and can see the current schedule. If you're close to the stage, you can see one more beacon. That's my bus stop at home. I did extend my bus stop to see the current schedule with a beacon as well, so my bus stop is part of the physical web. Well, it will not help you much because I'm from Düsseldorf, and I don't think that's a huge value for you to know when buses arrive and depart. But anyway, it works technical-wise, and that's the idea of the physical web. That's the Google slide where they describe that you can put a beacon on almost everything, and this thing gets a web address and is somehow connected with the Internet. But that's not the only way. There are a bunch of ways how you can get something connected, located, how you can add context to something, especially if you talk about beacons like kind of a proximity or a location service. There are much more ways to do that, and you have to decide which fits best for your needs. Bluetooth is not always the best thing you can do. I have some downsides later on. Anyway, you could use, for example, barcodes to scan to get detailed information about something. You can use NFC. Bluetooth is very much liked by a lot of people. You can use GPS for the exact position on the world. You could use Wi-Fi to detect somebody's position. Wi-Fi location is something we can use in several ways. You can use the IP, you can use cellular networks, the tower, for example, the telco. Knows exactly the position of the tower, and he knows which tower you are using. So you can estimate your position depending on the area where are you, sometimes on maybe 10 or 50 meters. Depends a little bit. So there are a lot of things you can do to locate something, to locate somebody. And again, beacons and the physical web is not just about location. It's more about the context, and that means sometimes you need only proximity, sometimes you need the exact location, and you have to choose wisely which technology might help you there. Here are two samples on your right side, describing a little bit the difference between location and proximity. The top one is a project we did with parcel services to locate the exact position of a parcel. Because there we have been interested in the route of the parcel and when this parcel might arrive. That was to check the performance of parcel services, and another scenario is to check, to secure parcels, to exactly know where they are so they can't get lost. And to do that, we used cell towers, we used GPS, we used SMS to send the information about the current position, but we always did send the exact position. We never use just the context because we have not been interested in the truck, for example, delivering the parcel. We have been interested in the exact position, but sometimes it's vice versa. Sometimes you are more interested in the context than in the exact position. And that's this sample here below. That's on a fair, a booth on the fair. We had to locate the employees working on this booth. And we tried to figure out at which desk they are standing. So there was kind of a high score, which employee on this booth is working hardest and the most time at his desk and something like that. But the exact position was not of interest. We just have been interested in the context, in the proximity. Is he just close to a desk? But we have not been interested where this desk in the world really is placed. So that's the difference between proximity and context. Back to the ways you can do that, the most famous way of proximity detection is somehow QR codes, quick response codes. But honestly, in most scenarios, they are not really quick. And they are not really a good user experience because you need to take kind of a photo. You need to take your phone to really use that. The light conditions are very important, and it's something you have to do explicitly. So that always involves some manual task by you. But if you use beacons, this automatic broadcasting of a radio signal, then it's more implicit. And light conditions, for example, don't care. So it's in some cases much more convenient. It's just a better user experience. But it depends. People need to have activated Bluetooth, for example. They need special applications. So sometimes QR codes or things like NFC might be a better choice. You have to decide. Some typical samples for the physical web. But what can you extend with a website? For example, again, a vending machine. So if you use that vending machine and you go to the URL, the website this vending machine broadcasts, you can do payment on a website, you can order goods. That's something we frequently did with several companies. And you can use that for maintenance reasons as well. You can place a beacon, a little bit like Amazon Dash buttons on a washing machine, for example, to gather some more information about how it works. Some home appliances companies do that, or you can order some additional supplies for this machine, for example, or for your printer, whatever you can imagine. The one below is a restaurant buzzer. So you get the information, your food is finished, if you use that based on that on a website. A parking meter where you can pay the parking bill. And last but not least, what I like quite much is a tiny toy with a unique website. And if you go to this website, you get a remote control in your browser using local Bluetooth to control the device. It's a little bit strange that you go through the internet to control your local device, but it's possible. So you can provide a remote control in the web, and to get there, you have a single URL combined with this device broadcasted by a beacon. And setting up the physical web is really easy. That's the reason why this kind of talk might be a little bit boring up to now. Hopefully it's getting more interesting, because everything you need is a simple Bluetooth beacon. That's everything you need. I've some with me, and if you later on, if you are interested after the talk, I can show the technical details, how they are built and how they look if you remove the case. For example, that's a physical web beacon which is built by Google and other company. That's an SD-mode one. And here, if you like, you can see how small they usually are. This, for example, is the inside of an SD-mode beacon. It's really small. It's smaller than the coin cell you use for that. Anyway, once you have that kind of beacon, you have only to bring a URL. You have to somehow burn a URL into this beacon. That means you just need URL. Unfortunately, this radio signal broadcasted by a beacon has a certain size which cannot be extended. And therefore, you have to use URL shorteners in most cases and some special patterns to get the URL into your beacon. And then, if you have done that, if you have followed this simple 5 steps, the last one is using it. You only need a device which can receive Bluetooth signals and which knows how to handle these URL beacons, these physical web beacons. That's it. That's everything you need. Again, how? Because most of you are, I suppose you are Android developers, so you know how it looks. On Android devices and on iOS devices, it looks quite similar. Well, you have your notification center, your message area, where you, once you have activated Bluetooth, once you have installed Chrome, once you have installed the physical web app, it depends what you prefer, physical web app or just the latest version of Chrome or both, then you get this message hits in your notification area and you can just hit on that, push on that, and you go to the website directly. And if you have a special type of beacon, for example, this physical web beacon, you also can just push a small button on the beacon and write a different URL on this beacon. So that's everything you need. You don't need to be a programmer. Almost everybody, including your cats and your cats also, but I mean your kids and parents, can somehow do the physical web. It's really, really easy. And this is just one part of what's Google doing in terms of IoT. This is part of the beacon platform, the physical web, sometimes referred to Eddystone, but Eddystone is much more than the physical web. I will come to that in a couple of minutes. There are some more things you can do if you like to explore Google products. For example, they have a bunch of operating systems for IoT devices, not just beacons broadcasting URLs. For example, you could use Brillo. Brillo is an Android-based operating system for somehow, in quotes, embedded devices, but it's still a huge operating system, so your embedded device needs at least the same power than most phones, than most mobiles. They are developing a new project. It's called Fuchsia, kind of a plant. That's an open source project right now. Also a new kind of operating system for IoT devices, but that time it's based on Dart, as far as I know. And Google Home, for example, is a gateway. They announced at the recent I/O, also for Internet of Things and Smart Home. And this gateway is based on, at this time it's based on Chrome. So you see there are 3 different operating systems, and I'm really curious how that will go and where this will lead, which of these operating systems we will use in the near future on what devices for which scenarios. Same counts for all these protocols you could use connecting devices. Weave is one, Thread is one, so there are so many things you could do, and I will show you some details on how you can do it later. Back to the beacons and the Eddystone platform. Eddystone is somehow the foundation of the physical web, but the physical web is just a small part of the Eddystone beacon idea, the Eddystone beacon platform. But all these beacons, all these Bluetooth devices in common have that they are technical-wise just advertise a series of bytes. That's it. And this series of bytes is very much limited. It's called scan record if you use it in Android devices to process it. It's very much limited. It has a very fixed structure, and everything you can somehow vary is this payload, the advertisement data. And this is something you can choose, where you can write down your own bytes. So you can invent your very own physical web if you like, because the structure is always the same, and there's not really a promising way to secure it. It's just a public broadcasting of data, of bytes. Well, there are some approaches to make it more secure, but these approaches, I don't believe in that. It's, for example, alternating the ID of this device, because every beacon has very much like a network device has a MAC address which you can use to detect it. So that's it. So you have just an advertisement package will be sent by a beacon. It's very much like an airport radio beacon, a radio signal broadcasted by an airport and received by airplanes to get somehow near this airport. It's very much the same idea, advertising the functionality, some data. There are a lot of companies doing that, a lot of different ways of using this beacon, this advertisement in Bluetooth. For example, Alt Beacon is the predecessor for Eddystone. Eddystone is based on alt beacons, is very much the same. Apple's iBeacon is the most known way of using beacons, iBeacon, but unfortunately they own the brand iBeacon, so you are not free in choosing that and using that in your products. They could sue you if you use iBeacon without having the permission to do so. SD-Mode is one vendor, Gimbal is one vendor, it's a daughter somehow of Qualcomm. Even PayPal is building their own beacon for payment systems. And they all follow the Bluetooth standard, which is somehow standardized, and even this Bluetooth Foundation, they have defined what a beacon makes, how a beacon works. They call it Bluetooth Smart Beacon. Everything is based on BLE, Bluetooth LE, and that is part of the Bluetooth 4.0 standard. So if your phone supports Bluetooth 4, you can do that. You can build applications like that. Some typical use cases are, for example, contactless payment. So if you leave a room or a shop, you get immediately charged for whatever you got in this thing because it's implicit. You don't have to do it actively, but you can do it actively as well, like NFC payment. It depends on the implementation. Proximity marketing, if you get close to a shelf, you get some extra information. Check-in, check-out, couponing, and even indoor location if you use triangulation. Because if you have more than one beacon, because one beacon is just proximity, you don't know where around this beacon you are, but if you have several beacons, you can, well, more like a rule of thumb, locate somebody in a room indoors. That's something a lot of shopping malls are interested in doing. As I mentioned, Bluetooth is one standard. It's using the ISM band. That means it's, as far as I know, a free band in the whole world. It's the scientific and medical band. So almost everybody can, using some rules, use that for his own ideas, and Bluetooth uses this band. Almost all phones support Bluetooth. 90% of phones have Bluetooth built in, so it's one of the widest distributed kind of connectivity you can use. And most people use for beacons use the proximity, the received signal strength indicator. So that means the energy of the radio signal once it arrives at your receiver. And this is something we can use to somehow guess the proximity, how far it is away. It's a little bit difficult to get really sufficient proximity values, but as a rule of thumb, it works quite great. And BLE just uses reduced power, so your devices will last. That's one of the differences compared to Wi-Fi, for example. Your devices will last a little bit longer using Bluetooth than using Wi-Fi nowadays, but there's some development going on for several Wi-Fi standards using similar kind of energy. So it's an ongoing development and research. Anyway, I would like to give you two samples of glitches you can have using Bluetooth. The latter one, with all these different Android versions, is that there have been some serious troubles with 4.4.3 devices using Bluetooth. So I strongly recommend using at least KitKat. And to be honest, I won't start a beacon, a Bluetooth-based project for Android devices below 5.0, below Marshmallow, because there are so many specialties and a lot of frameworks do not work with that correctly. So that's my recommendation. But starting with Android 5, everything works quite smoothly. And in real world, with the physics, there are a lot of gotchas you need to know, because the signal might get reflected by walls, for example. Sometimes you have some kind of attenuation, so the signal will be lowered because there are some fluids or wood or furniture in the room, and you have to take all these things in account. And we made some funny experience doing projects like that. I remember that's the reason why I have a picture of, at that time, the heaviest person in the world, because this Bluetooth-based proximity detection on the fair, I've shown you a couple of slides before, where We try to detect employees on a fair and how far away they are from their working desk. We did test everything, and we did implement that. I even did build a small Lego car to drive around with the beacons to show how it feels if you go away and come back. And we did a lot of effort, and everything worked fine, and we installed that, and it was the first time used in the US, and we always got strange results. Some people haven't been able to really check in their work desk, and we couldn't figure out why until we discovered that only happened to very, how can you say it, very large persons, because of this amount of meat around them. It's a lot of fluid, and then we get totally different results. So we had to change the whole user experience. We had to force them to use the BLE broadcasting thing in front of them, like a name tag, to get rid of this attenuation through their body. So that's something which I highly recommend, that you test a lot, and that you test a lot with different persons, different environments. Even the weather has an impact on Bluetooth signals. If we talk about Eddystone in general, that's literally Bluetooth 4.0, it's Bluetooth LE. It's very much the same like iBeacons made by Apple. It's just a little bit a different structure inside the advertisement packages. And they have one specialty. They broadcast different so-called frames. They don't just broadcast one signal, they can broadcast several signals, and they can use different schedules for the signals. For example, they could send a unique identifier for proximity, for URLs, or whatever, each second, and they can broadcast telemetry data, for example, temperature, something like that, energy consumption, battery voltage, for example, every 10 minutes to reduce power consumption of the device. That's something very special for Eddystone, and it's an open standard, so you could invent your own frames if you like to. You could build your own devices, you could build something for your own scenarios. Here was one scenario where we used beacons that's for contextual reading, contextual content. If you imagine you're sitting at the doctor's and you wait for your appointment and you like to read some magazines, nowadays some doctors, they have that in a digital version, so that means only if you're in their waiting room, you are allowed to read these newspapers on your device, on your phone. And they detect if you're in this room, for example, based on proximity beacons on Bluetooth. Some do that based on IP location. Even some bookstores nowadays use that, so that you can read a digital version of a book inside the bookstore, but once you leave the bookstore, you can't read that anymore. Well, the most boring example, because that's the one most people speak about, talking about beacons, is proximity marketing. Once you get close to a shelf with certain products, you get some additional information about the products, some additional advertisement, more or less. One more sample is couponing and ticketing. The MLB, the Major League Baseball in the US, they use it in some stadiums, and then you get some coupons for cheaper sausages, for example. They broadcast a message, now there's a special bargain for the sausage close to you or for the beer close to you. Or you can do ticketing. Your ticket could be in a digital way and broadcasted, identified via Bluetooth. I love this sample. Maybe you see the failure. Hope you got the failure, because have you seen that's somehow presence detection. If you get close in a hotel to the door, thanks to Bluetooth, the door opens automatically. What I totally do not understand in this video, why does this wife have to move her hand like using keys? I don't get that, because if you get close to a door, it should just open, because that's a new innovation, because in this case it's just a replacement for a key. But I was told, I'm not sure if that's the truth, but I was told that they have a patent on this gesture, using a Bluetooth device like a key, and that's the reason why they have built it in. I'm not sure. One more sample is tracking sports devices. This is done by an agency to force their employees to make more sports, and therefore they have installed some beacons in the stairway to the office so that the people use the stairway instead of the elevator. It's just one more idea what you can do with that. Securing stuff is almost quite interesting, that you put a beacon on your keys or on your phone. I sometimes have a beacon in my luggage because I tend to fall asleep in trains, so if somebody else would take my backpack, I would get a notification that this gets out of my near proximity. One more umbrella is the same issue. It's a little bit like losing your keys. You get a reminder if you go away from your umbrella. But this is sometimes a little bit more sophisticated. It could be connected to the actual weather. So if you leave home, then sometimes you don't want to take the umbrella with you, and then the umbrella checks, will there be rain? Because you are leaving, and then only if there will be rain, it will notify you about that via Bluetooth. Payment, I already said there are several ways how you can pay thanks to Bluetooth beacons and the physical web at all. So that's what you can do. Well, what do I do if I want to build projects? You can see that here in this small video, we set up our own environment, and I love to use toys to make showcases, to make prototypes. For example, we did build our own Bluetooth watch. It's based on a custom-built small self-soldered Arduino. It's a Raspberry as receiver. This Arduino is a Bluetooth sender, and I have a kid's construction kit with some electronics to try that out. So that's one part of the hardware. The other part is the logic, the coding. For example, I love Node-RED based on Node.js to build scenarios like that. So if you have Node-RED running on a Raspberry, for example, you have your receiver, you have your broadcaster, then it's really easy to set up showcases, scenarios to experience the ideas you have. You furthermore usually need kind of a Bluetooth scanner around you. The NRF master control panel is one of the best Bluetooth tools you could use to get all the scan records to discover how they work. And then finally, the coding is starting. And coding is really easy. That's the reason why I did tell you so much general stuff, because it's so little you need to know. There's only a few lines of permissions you need. For instance, you need to give it the general Bluetooth permission. That's obvious. And then you need the Bluetooth admin permission for scanning Bluetooth devices around you. And then you need the access coarse location. That's a change since Android 6, since Marshmallow, because before that you didn't need that. That's one more permission you have to give to your application. And last but not least, it's quite nice if you just limit your application to devices supporting Bluetooth. That's this last line here. So people without Bluetooth, they can't install your application. But that's something you have to decide yourself. Maybe your application works without Bluetooth as well. So that's what you have to do in your manifest with permissions, quite easy. Then you have to declare the code, your instances you need. You need the Bluetooth manager, which gives you just the service. You need to get the Bluetooth adapter. That's the next one. And that's also a small change to Marshmallow from the former version of Android. You need the Bluetooth BLE Scanner as an instance. For that was just a method you could call. And that's everything you need to start. There's one more interesting thing. There is a service UUID to identify your kind of beacons. And all Eddystone beacons, they broadcast FEAA. The rest, it looks a little bit strange, this whole UUID, this whole parcel. But you only need FEAA. The rest is just a template. It always looks the same. FEAA is a unique ID for this kind of beacons. And then you need to know the different frame types for UID, URL frames, and telemetry, and whatever they want to invent. Next is just writing the real code beside declaration. So I get the service, I get the adapter, and finally I start with the Bluetooth BLE Scanner. I get this one as well as an instance. The special code for permission management since Android 5. And there now comes the interesting part, reading the scan record, the advertisement, the payload you receive. And this is just a series of bytes. And there, for example, you see FEAA, but vice versa. They just changed the order of the service UID, but it's not that interesting. The interesting part is the red part, where you get the frame type, you get some information about the sending power, you get the namespace. So that's the UID, very similar to what iBeacons do, and the instance. Namespace and instance make up the UID. So that's just a simple UID scan record. And this is what you finally read in your code. You have a callback object with the onScan result method, and there you can get all these details. You can read all the bytes of that. And last but not least, For example, you also can read the RSSI for detecting proximity. That's what I often do, and this is a sample doing that with a small RC card measuring the round times. Each round for battling with my son in our garden. You see there's the car with the beacon in the back, and there's a quite old phone just receiving the beacon signal. It's kind of a stopwatch. If you want to extend that a little bit, this is the same sample using sensors, telemetry. It's very much the same. I'm doing, in this case, I set a scan filter just only to receive the appropriated beacon signals, not everything. I changed the frame type because the frame type now is 20. There are some additional bytes I can read for the temperature and the battery voltage. And this looks a little bit more sophisticated because I have to read all the bytes and to build the real values out of the bytes. And to sum that up, after this session, I will tweet a message where I will give you a URL with a very big talk, including video, samples, code snippets, a slide deck where you can read that all, where you can get all the things if you want to get started. Anyway, everything feels like these beacons, IoT devices will get everywhere in the world, like cockroaches, everywhere. There will be 2 million new sensors each hour starting 2025. That's approximately what UIY thinks. And now, also nowadays, even we are not there, but nowadays people use that, for example, for turning cows into somehow industrial machines to measure their temperature. They use sometimes Bluetooth or other near-field communication ways to detect that. But this scares me a little bit because that's still a living form. And now they turn it into a machine, and it's getting even worse because some people do the same with their kids. They use beacons, Bluetooth signals in the pacifier, and they measure the temperature of the child each day. That's something which really scares me. Even further, some people use connected, in this case just via the web, toy dolls to observe their kids. So it's a little bit like the house at the beginning. It's called, in this case, it's called Hello Barbie, or this is another version, it's called My Friend Kayla. And kids can talk with these connected devices and give these connected devices their personal secrets, and parents then afterwards can broadcast, they can browse through all these secrets on the website, read all this, or listen to all these snippets. Yeah, and this is not that new. For example, in 2001, even The Simpsons, they made a sample of a connected, in this case, home, where they have a connected, very empathic home, which serves the favorite meal of everybody based on sensor data. They use the leavings of the family to detect what the people like most. Unfortunately, at the end, the house falls in love with Marge, and everything got a little bit complicated. Anyway, that's something already there in the market. There are some vending machines doing that. But I like, because I'm running out of time, I like to show you one final sample, how that might look like. Hopefully, you can... Okay, I will do the best I can. So it is. There you see me. And I have here, for example, I have Minecraft running. And I like to show that to you, that I am able to connect the virtual world for showcases, for example, to in this case, my smart home environment. That's, for example, Minecraft. You can see that. Here's a light bulb, and I hope it will work well. That's something I did for my son, and I have plenty of samples doing that. And now I can start here with this chick, and I can destroy this chick, and the light should turn on. Did it turn on? Yes, so unfortunately we don't have... Oh, I can make rain as well, and snow. There's a chick, and I try to get behind that, and if I hit it... Oh, it's going away. If I hit it, I get the light again. Anyway, I like to show you some more stuff, because that's one more device I like to connect with that. It's, in this case, it's not Bluetooth, it's Wi-Fi. It's a BLE connected device. So that's plus, and hopefully I get a connection. And once it is connected, I can start it. So you can see the idea. By the way, I don't have any clue of how to use Minecraft. That's the reason why I sometimes make talks together with my son, because he does the Minecraft part. I only can code it. So we see if I get the data. Now I've connected this stuff, and I can just, for example, change the light, and it's getting night. And again, it's getting day. And I can, a little bit like a Bluetooth beacon, I have built-in proximity detection as well. If I'm close to this chicken, I get this signal, and if I go away, the signal stops. I hope you hear it. I built that for my son because he is somehow addicted to Minecraft, and he doesn't like to go away. But thanks to this device, he can take this device with him going to the toilet, for example. And if there is a creeper or a chicken close to his avatar, he can run to Minecraft to kill or destroy it. And I also did connect that with our smart home. So there's a smart home we're using. It's based on KiwiCon. Here I have the sibling. It's called Open Up. It's an open source smart home. And I can use that, for example, to close doors in Minecraft, to use a Bluetooth beacon to open doors automatically in the real world and in Minecraft, and vice versa. So if somebody really is way too much into Minecraft, he can combine that with his real world and make some experience. And last but not least, otherwise I get in trouble because I need too much time. Last but not least, that's something I do together not only with my kids and my family, I also do that, this combination of all these toys and technique, beacons, ESP chips, Arduinos, Raspberry Pis, for ideation. Because this kind of ideation, this leads into, most often it leads into real world products, into good ideas, and thanks to this somehow childish approach, you get results very soon. You know very fast, it makes it sense to start developing a real-world project. And you can inspire your customers. We use that in workshops, for ideation workshops and things like that. It feels a little bit like playing Lego, because you start quite rough with a single brick, and then you extend this brick step by step, very agile, with more real-world details. So that's what I do once I try to build IoT scenarios, and I'm forced to stop here. Unfortunately, I have dozens of samples, so if you like to see them or to discuss more details, if you like to know more about the Internet of Things and physical web, come by during the lunch break, and please follow me via Twitter. That's SASCHAWOLTER, because I will send the link to the more detailed information later on. Thank you so much for your patience.